Everyone knows when you're sitting in a meeting room, for example, with a bunch of people, maybe it's about 15, 20 square meters, then every single person in this room will be using oxygen and producing CO2. It's when we breathe in fresh air at about 400 ppm, then we convert this into CO2, and when we breathe out, actually, there is 40,000 ppm in our breath. That means from 0.04% of CO2, we go to 4% of CO2. So that means if you do not have good ventilation, the CO2 level in a meeting room or any other closed, confined room will actually increase. And this does have an effect. Normally, many people will have noticed that in a long meeting, you get more drowsy, you get more sleepy and less focused. And this is both the effect of less oxygen, but also an effect of increased CO2 in the air. When you go even higher up, for example, a normal meeting room maybe has 1,000, 1,500 ppm of CO2. If you go higher up, like 3 or 4 or 5,000 ppm, which is found, for example, in the space station or in a submarine, then you have even more effects on your body. They will make you much more sleepy, and it will be much harder to concentrate. That's why it is important to measure how good your air is inside. Another point is that if you have more people, you will need to exchange more air in your meeting room, and this will cost more energy. If the outside air also has higher CO2 levels, then you again need to exchange more air in order to have fresh air inside. When you look at the legislation, actually for a normal building, the target is that the CO2 level inside should be below 1,000 ppm. When you go up to 5,000 ppm, then in the US, that is the maximum that is permissible during an 8 hours workday. If you go even much higher, at around 70,000 ppm, you will start to faint, and maybe you even go into a coma. So luckily, these levels we will never achieve inside. A human person produces about 300 milliliters of CO2 per minute, and then you can do the math easily. That's about 18 liters of CO2 per hour per person.